Dear viewers, welcome to the YouTube channel H2O Chemistry. In this video, I'm going to discuss the concept called electromagnetic separation or magnetic separation, which is one of the concentration method we use to concentrate the ores. Let us see the principle. The electromagnetic separation is otherwise called magnetic separation. The principle behind this method is a difference in the magnetic particles of ore and the impurities. For example, when you take a sand from the any roadsides or something, and when you add it to the paper, you pour it to the paper, and below the paper, you place a magnet. Some magnet particle will be there that will be attracted towards the magnet, whereas the other magnetic particle will be there in the paper and left behind the paper, whereas the magnetic particle will move when you move the magnet. The very similar idea is used here in the electromagnetic separation. So this method is based on the difference in the magnetic particles, magnetic properties of the ore and a gung. The magnetic property of a ore forms the basis of the separation. Here, either the ore is magnet or the gung is magnet. It may be a vice versa process. Is either ore or a gung is magnet. If ore is magnet, gung is a non-magnetic particle. If gung is a magnet, ore is a non-magnetic particle. For example, we will see a tin stone can be separated from wolframate. The wolframate is a magnetic particle. A tin stone is a ore, whereas wolframate is a impurity, or as we call gung. Here, the gung is magnet, the tin stone is non-magnetic. Whereas the other ores such as chromite, pyrolusite, or having magnetic property can be removed from the non-magnetic substance like silicon impurities. Siliceous impurity means the compound based on silicon is called siliceous impurities. So, which is generally non-magnetic particles. Okay, you could see the diagram here clearly. The powder ore is poured in the conveyor belt. We call conveyor belt. There are two rollers, one of which is magnetic. You could say this roller is magnetic wheel, as a magnetic wheel. So when the powder ore falls on this conveyor belt, this magnetic wheel will attract the magnetic particle and will take that along with the wheel and pour it into separate container, whereas non-magnetic particle will fall as a separate heap in the separate container. This is an idea, right? So the movement of conveyor belt will be in this direction from right to left, but when you go down it goes to left to right. It's very simple idea, my dear children. Let us see the method. The method you can see clearly here. The crushed ore is placed in the conveyor belt through feeder, which rotates around two metals wheels, one of which is a magnetic one. The the magnetic particles are attracted towards the magnetic wheel and falls separately as a heap apart from the non-magnetic particles. You could see the magnetic particle separately makes a heap, whereas the non-magnetic particle separately makes a heap. So in this manner we can separate the ore particles or gung particles. So we can separate majorly. So this is the method employed for tin stone. It's an important 1 mark too. So make it, please remember and keep it in your mind. And next, the other setups we can see clearly here. The same diagram which is given in your book, so you can refer this. This is another separator, magnetic separator. This roller is a magnetic one, so it separates the magnetic particle separately and the non-magnetic particle is here. So this is an idea used, my dear children. I hope this video will be very helpful in learning the electromagnetic separation. If you like this video, you can subscribe and click the bell button to get the notification instantly. Like, command, share it to your friends, let them learn. Thank you.